This is 2012 FRQ number 3. We are now on to the non-calculator portion. All right, so let f be the continuous function defined on -4 to 3 on this graph. Consists of 3 line segments and a semicircle centered at the origin. So 3 line segments, semicircle, line segment. And g is the function given by g of x is the integral between 1 to x f of t dt. So again, remember there's a really cool relationship here. Your g of x function is the integral between 1 to x f of t dt, meaning it's the area under the curve. All right, g prime of x means you take the derivative, which is just f of x. So this is just the graph. G double prime of x is the derivative of x, which means you're looking at the slope of the graph. Okay, now you have this relationship. It's a lot easier to figure out what they want. Okay, so first one says, find the values g of 2 and g of -2. So part A, you kind of just follow the formula. G of 2 is equal to integral 1 to 2 ft dt. And g of -2 is 1 to -2 f of t dt. Okay, so what does that mean? First things first, this integral is right because it's going from small to big. So I want the area between 1 to 2. So it's going to be right here. 1 to 2 is this really tiny triangle. It's below the x-axis. So you know it's going to be negative. So it's going to be negative 1/2. Base is 1. Height is 1/2. How do I know that? Well, you look at the values here. There's a linear function. So if this is down to -1, it's halfway. That's -1/2, right? So my area is -1/4. Okay, that's g of 2. G of -2, okay, so this is in the wrong order. So put a negative in front. -2 to 1, f of t dt. All right, so clean this up. My area, I want -2 to 1. So I want -2 to 1. I want this triangle here. Now this is on top of the x-axis. Oh, sorry, -2 to 1, all the way to 1. Oh, that's everything. Okay, so that's going to be a positive triangle minus a semicircle. Okay, so 1/2 base of 1, height of 3, minus semicircle. So it's 1/2 pi, radius square, radius is 1. So that's 3 over 2 minus pi over 2. Right. Now, don't forget, this is my integral here. There's a negative in front. So you're going to put a negative in front, which makes it pi over 2 minus 3 over 2 as my final answer. Okay? All right. Part B. Part B says for each g prime of -3 and g double prime of -3, find the value of a state that doesn't exist. Okay, so g prime of -3 is equal to f of -3, right? G prime is actually the graph. So f of -3, 1, 2, 3. -3 is right here. Again, using the fact that it's a linear function, if you look at the slope, you will see that this is going to be 2. So the value is 2. Okay. G double prime of -3. So what is the slope at that point? Well, y2 minus y1 over x2 minus x1. So y2 minus y1 minus 1 over x2 minus x1. So 2 over 2, that's 1, right? So the G prime is 2, G double prime is 1, okay? All right, so now, let's see. Find the x-coordinate of each point at which graph has a horizontal tangent line. For each of these points, determine if g has relative minimum, relative maximum, or neither min nor max at the point. Justify your answer. So when g has a horizontal tangent line, that means then the slope is 0, right? So that means you're looking for when g prime equals 0. So again, read the problem correctly. I'm looking for when g prime equals 0. G prime equals 0 is when is the graph equal to 0? The graph is equal to 0 at -1 and 1. So at -1 and 1. So what are these? Are these actual maximum minimums? Well, at x equals -1, what's happening? It went from positive to negative. Positive right? The graph went from positive to negative. That means then G prime, the slope went from positive to negative. It went from positive to negative, increasing, decreasing. Therefore, this is a maximum. Right? At x equals 1, well, my graph is negative to negative. So negative to negative. So neither, because there is no sign change. So it's neither a max or a min. Right? It could be something else, which we will find in part D. All right. For the entire interval, -4 to 3, find all the values of x in which the g has a point of inflection and explain your reasoning. So to have a point of inflection, your g double prime has to equal 0. So g double prime of x equals 0. That means the slope of the graph is 0. Slope of the graph is 0 here at -2. Slope of graph is 0 right here at 0. Slope of graph is 0 here at x equals 1. Okay, so are these truly point of inflections? Well, let's see. At x equals -2, the slope of the graph, right? The slope of the graph went from increasing to decreasing. So it went from positive to negative. So yes, this is a point of inflection. Here at 0, slope went from decreasing to increasing. So decreasing to increasing. Yes, this is a point of inflection, right? And then at x equals 1, my slope went from increasing now to decreasing. So increasing to decreasing. So yes, this is all point of inflection. So sign changes. These are all point of inflection. Okay, that's it.